So welcome back, everyone. We're going to continue with our suite on inequalities. Last time we just showed you the basic ideas of what less than, greater than, less than or equal to than, greater than or equal to than look like and how to picture them on the number line. Now we'll get a little bit more technical, nothing too technical, and show you how to do some algebraic manipulation with inequalities. We'll start by reminding you how to do it with equalities. First, what you do mechanically and why you would do it. The reason you do it is to solve for x. Then we'll show you what is probably some new stuff, which is how to do it with inequalities, what works, and then a very, very big warning that there's one thing you can do with algebra with equalities, namely multiplying by negative numbers, that you have to be very, very careful about with inequalities. To give away the punchline at the beginning, the only real difference is when you multiply by a negative number in an inequality, you have to flip the sign, and we'll show you what that means. Let's get into it. Okay, first, what is probably some very, very familiar material, let's talk about algebra with inequalities. Suppose we start with something really simple, like 4 equals 4. Here's something that seems so obvious that no one really appreciates what a powerful tool it is in your algebraic arsenal. What am I saying? What I'm saying is that if you take an equality and add the same thing to both sides, so let's take 4 and let's add 3 to the left side, let's add 3 to the right side, and let's put the equal sign here, this is still true. If 4 equals 4, then 4 plus 3 equals 4 plus 3. In fact, this is equal to 7, and this is equal to 7. So let's put that as a general rule. If A equals B, then A plus C equals B plus C, where A, B, and C can be any numbers, positive, negative, integers, fractions, whatever. Who cares? Well, who cares is this allows you to do algebra. For example, suppose someone tells you there's a mystery symbol called x, and x plus 3 equals 10, and they demand that you solve for x. Meaning what they're really asking is, what is x if x plus 3 equals 10? With a simple one like this, you can sort of stare at it and say x probably has to be 7, but you can also do it rigorously and technically using this algebraic rule, this tool you have in your arsenal. How could you do it? Well, you look here and you want to isolate x. If you knew that x was equal to something, you'd be done, because that's what it means to solve for x. So let's isolate it by getting rid of the thing next to it. Let's subtract 3 from both sides. In other words, if we write x plus 3 minus 3, this is equal to 10 minus 3. X plus 3 minus 3 is equal to x. 10 minus 3 is equal to 7. And hooray, we found out what we wanted to find out, which we sort of knew already. Okay, so that's nice. Let's start again with 4 equals 4. And let's multiply it by, say, 2. 2 times 4 equals 2 times 4. This works. This is 8 and this is 8. So I can multiply by a number. I can also multiply by a negative number. So if I start with 4 equals 4, and I multiply by negative 3. Negative 3 times 4 equals negative 3 times 4. Over here this gives me negative 12. Over here this gives me negative 12, and I'm happy. General rule. If A, B, and C are numbers, and C is not 0, and A equals B, then C times A equals C times B. Who cares? Well, again, it allows us to do algebra. So suppose someone comes along and says, minus 5x equals 15. Hey, you solve for x. So we have to stare at this. If you're a little practiced, you can probably figure out that x equals minus 3. Another way to do it is let's isolate the x. X is being multiplied by minus 5. I need to somehow cancel that out. Let's multiply by negative 1/5. Right, so I multiply by negative 1/5 times minus 5x. That's equal to negative 1/5 times 15. Negative 1/5 times minus 5 is 1. So this gives me that x is equal to minus 15 over 5, which is minus 3. X equals minus 3. I circle it and I'm happy. Okay, fine. So that tells us that those two algebraic tools in our arsenal, that you can add the same thing to both sides of an equation and you can multiply both sides of an equation and still say true, allow us to solve for things. Okay, let's go toward inequalities. Suppose I start with 4 is less than 7. And suppose I add something to both sides. So 4 is less than 7. Is it true that 4 plus 2 is less than 7 plus 2? Yep, because 4 plus 2 is 6, 7 plus 2 is 9. That works. Hooray. If I start with 4 is less than 7, and I subtract something. So say 4 minus 1 is less than 7 minus 1. That works. That says that 3 is less than 6, and that works. So, general rule. If A is less than B, then A plus C is less than B plus C. For any numbers A, B, and C, we can even picture that on the number line. Right? Suppose here's A, here's B. That means A is less than B is to the left of it. And I add C. If C is positive, that means I'm shifting A by C and I'm shifting B by C. There's no way that A plus C can jump over B plus C. Likewise, if C is negative. That's why that works, and that's often very powerful. That allows us to do algebra with inequalities just as before. So in other words, suppose someone tells us that x plus 3 is less than 10. And they ask us to tell us more about what that means about x. So if x plus 3 is less than 10, I can subtract 3 from both sides. And you all are sort of practice with that, so let's just see. If I subtract 3 from the left, I get x. If I subtract 3 from the right, I get 10 minus 3. In other words, x is less than 7. So what? Well, what does that mean? That means that whatever on earth x is, and it could be anything, it's not one particular thing, it has to be to the left of 7. In other words, x has to live in this blue zone here. Any number it wants to be as long as it doesn't exceed 7. And that's what the information that x plus 3 is less than 10 looks like. By the way, in a later video, we're going to talk about this being a half-open ray. This is going to be a symbol minus infinity to 7, and x is in there. We'll tell you what that means, so don't get confused about it now. I just want you to see that in advance. Okay, that's great. Now, here's a little warning. When you multiply inequalities by both sides, it's a little more dangerous. Let's start again with 5 is less than 8. And first, let's multiply both sides by a positive number. So, for example, 3. 3 times 5 less than 8 times 5? Question mark? Yep, that works, because 3 times 5 is 15. 8 times 5, oh dear, arithmetic in public. 8 times 5, gears churning, whir. 8 times 5 is 40. I think that's right. So 15 is less than 40, and that works. Here's a problem. Let's take 5 less than 8, and let's multiply both sides by a negative number. Say minus 1. I do minus 1 times 5, and I ask, are you less than, question mark, minus 1 times 8? Turns out we get an electric shock through the keyboard if we even try to write this. Because minus 1 times 5 is minus 5. Less than, question mark, minus 8. No way, right? Here's the real number line. Here's 0. Here's 5. Here's 8. Unfortunately, here's minus 5. Here's minus 8. Minus 5 is not to the left of minus 8. This is completely awful. In fact, what is true is that minus 5 is greater than minus 8. Here's the general rule. Suppose A is less than B. If C is greater than 0, A times C is less than B times C. But if C is less than 0, then A times C is greater than B times C, just as we saw here. So you have to flip the inequalities. Let's see one example of that. So I do a little bit of algebra. Suppose someone tells us that minus 2 times x is less than 10. What does that mean about x? Well, let's multiply both sides by minus 1/2. So if I multiply this side by minus 1/2 times minus 2x, multiply this side by minus 1/2, minus 1/2 times 10. But now I have to flip the inequality, right? Because I've multiplied both sides to an inequality by a negative number. This gives me x is greater than minus 5, which pictured on the real number line. Here's 0, here's minus 5. And that means x can be anything in here. So if x is anything in here, and I feed x to this equation up here, this inequality up here, I make it true. That's really just the only pitfall you have to worry about, but it can be a serious one. Okay, that concludes our video.